hope you enjoyed Christmas break, and now we have another video. Today I want to discuss why we use thermal windows and what is the principle behind it. Thermal windows have two glass layers. Let's say this is first glass layer and this is second glass layer, and there is an air trap between these two glasses. And why do we have air trap? Is because air acts as good insulator. It traps the heat and don't let the heat, let's say this is my room here and this is the outward atmosphere, which is colder than my room temperature. Now if my room is hotter than the environment, this side, the left side of the window, would be warmer than this side of the window. The air trapped in between would have different temperature difference. The particles which are in contact with this layer would have higher temperature than the particles which are in contact with this layer. But definitely these particles which are here, which has higher temperature, would gain momentum because of higher temperature from here. They get higher temperature, and because of that they get kinetic energy and start bouncing outward from this region towards the region which is cooler than this former one. Now these moving particles will carry energy, and this is given by n by 2 kT. So energy of these particles, these moving particles, would be given by n by 2 kT. So energy here depends upon the temperature. Higher is the temperature, higher would be the energy. N represents the degree of freedom. Now to understand degree of freedom, let's start with simplest molecule. Let's say we have inert gas molecule, let's say argon, and the argon molecule is capable of having just one atom. So let's say this is my argon atom, this is just a duster, but for now just consider it like that. Okay, so this is my argon molecule and this is single molecule. So it has 3 degrees of freedom. It can go in x direction, y direction and z direction. Okay, so it has 3 degrees of freedom. So energy for this argon molecule would be given by 3 by 2 kT, where K is a Boltzmann constant and T is a temperature. So higher is the temperature over this region, higher would be the energy of the particles which are in contact with this layer of the window. But if we have diatomic air, for example oxygen, let's say something like that, we have 2 oxygen atoms and there is a bond between the two. Okay, so this oxygen molecule O2 can go in x direction, the whole system can move in x direction, y, z, or it can also stretch, go forward and back like that. It can also rotate over this axis, and it can also rotate about its own axis, which means we have 3 plus 3, 6 degrees of freedom. 3 along x, y and z, 3 plus 1, 2 and 3, compression and extension. So oxygen molecule will have 6 degrees of freedom. So energy carried by this oxygen molecule would be 6 by 2 kT, which is 3 kT. Now this means that energy carried by oxygen molecule is much greater than the energy carried by argon molecules. The take home message is to use the air which has one atom, which is non-diatomic or triatomic, because if you will use air as insulator which has more atoms in a molecule, it will carry more energy from your room towards the outside, and your room will become cooler very quickly. And we can't definitely use vacuum for a long time, because vacuum region will have no pressure from inside to equate or to balance the pressure which is acting on the outside because of the outside atmosphere and the bouncing of the molecules. So better to choose the air which has sinks. Okay, so and remember the formula n by 2 kT, and you will never be wrong. I'll see you in next video. Bye and take care. The take-home message is to use the air which has one atom, which is non-diatomic or triatomic, because if you will use air as insulator which has more atoms in a molecule, it will carry more energy from your room towards the outside, and your room will become cooler very quickly. And we can't definitely use vacuum for a long time, because vacuum region will have no pressure from inside to equate or to balance the pressure which is acting on the outside because of the outside atmosphere and the bouncing of the molecules. So better to choose the air which has single atoms. Okay, so and remember the formula N/2 kT, and you will never be wrong. I'll see you in next video. Bye and take care.